Shall I start?
Yes, sir.
Wait for 1 minute. Abdul Razak was regular, Rutri was regular, Lokesh, first time I'm seeing. Mekala regular, Pratish Paul regular, Raghavendra regular, Rakesh, I don't remember. Ritesh is the first time. Sushil Kamawat is also first time seeing his name. Umesh, I'm not seeing his name for the first time. Where were you these many days? This is my 18th class. Huh? This is my 18th class. I'm about to complete the first module. Sugun is regular. I don't know, really, I don't understand. This is a difficult subject, is a difficult to pass, at least get minimum marks, mind it. It's not so easy. Some theory questions it mug up and will pass in the examination. Rakshit is also, I think there is also attended very few classes. I've not seen his name. Shashi Kumar, I've never seen his name. Okay. So, I should have been told you that. See, I made a small mistake here. See, when I'm talking about stresses, since the diagonals are subjected to tensile and compressive stresses, this cannot be shear stress. This cannot be shear stress. This is the normal stress. This, sorry, I cannot erase this. I don't know why. Sorry. Let me try. Okay. This cannot be, since the diagonals are subjected to normal stresses. This is nothing shear force by area. It is subjected to a normal stress, normal tensile force of tau and normal tensile compressive force of tau. This is normal stress. Right. Give me a moment. Okay. Shear stress by area. This is the normal stress. Normal stress. The normal stress or axial stress, this normal stress of magnitude tau is acting on one of the diagonal and this tensile, and the other diagonal is of the same magnitude tau and is compressive. This is normal stress. Normal stress, which is equal to, even though normal stress is indicated by sigma, but in this case, our normal stress is tau. Our normal stress is tau. I can say this, I have to replace this by, resultant force. Resultant force by area, which is equal to normal stress, and this normal stress of magnitude tau is causing tensile on one of the diagonal, and the other diagonal, this is of compressive of magnitude tau. Since there is I'm running out of time. That is, we should finish off this. I'm in a little hurry. That's it. It's not a problem. Just because I in the theory classes, in the actual offline classes, I used to take 1 or 2 classes for 2 classes itself for derivation of this. But since we are running out of time, I'm little hurry. Okay. Now let us write the sketch once again. This diagonal, I'll call it as AB, CD. There is an expansion. I'll call this as AC dash and CD dash. Okay. Now we've also done that. So derive that. This is one of the diagonal. One of the diagonal is under tension. Other diagonal is under compression. Okay. Now, what this, if I call this as gamma, if I call this as gamma, we know that change in angle is our shear strain tan gamma. Tan gamma is given by CC dash by BC. CC dash by BC. Since gamma is very small, since gamma is very small, tan gamma is approximately, I'll write it here. Since gamma is very small, tan gamma is approximately equal to gamma. So I can write gamma is equal to CC dash by BC. Okay. Now, if I consider angle CAB, if I consider from triangle CAB, angle CAB, or I can write, okay, sine angle CAB. If I take sine of angle triangle CAB, which is equal to sine 45. If I assume that this is 45, this is also will be 45, obviously. 45. I can write sine CAB. If this BS is the hypotenuse, let me take angle CAB. I can write this as BC by AC. BC by AC. Okay. Or BC is equal to AC sine 45. I will call this as 1. Hope you're understanding this, right? Next step. See, always you should remember that this is from geometry. If I take like this, if I call this as F, triangle CFC dash is a isosceles triangle. Isosceles triangle in the sense two angles are equal. One angle is already 90 degree. Other two angles should be 45 degree. So that it is equal to 180 degree. For two angles are same for isosceles triangles. One angle I would define it as 90 degree. The other two should be 45 degree. Okay. From triangle CFC dash, I can write cos angle CAC dash, sorry, CFC dash, cos angle CFC dash, F is my angle, sorry, so cos angle CFC dash, I can write cos 45, which is equal to FC dash, FC dash, if I take as angle C, FC dash divided by CC dash, FC dash by CC dash, or CC dash, which is equal to FC dash by cos 45. I'll call this as 2. Okay. Now we know that gamma is equal to CC dash by BC. Okay. From expression 2, I can write CC dash is equal to FC dash by cos 45 and BC is equal to AC sin 45, or which is equal to gamma is equal to FC dash by AC 1 by cos 45 into sin 45, or which is equal to FC dash by AC into 1 by root 2, 1 by root 2, or if I write here under, try to adjust, gamma which is equal to FC dash by AC 1 by root 2, 1 by root 2, it's 2, 2 times FC dash by AC. This is the important relation. Okay. Next we have derived gamma. Now from geometry we can write, AC is equal to EF. If you are interested, I can tell you once in another class, or you can ping me. From geometry, how AC is equal to EF, I can discuss. From geometry, AC is equal to EF for small angles. Okay. Therefore, if you consider this, if I consider this diagonal AC dash, actually the diagonal was AC. Now it has turned out to be AC dash. The increase in length is FC dash. So I can write change in length by original length, FC dash by AF, or I can write FC dash by AC, change in length by original length. I can write epsilon, which is equal to change in length FC dash by AC. Since AC is equal to AF, is equal to AC by AF. This you should understand. Since when there is an increase in this, actually AC and AF are of equal lengths for small angles of gamma, and then there is an increase in length by FC dash due to my tensile normal stress acting along the diagonal. Similarly, there's a decrease in length in along the diagonal BG dash. So if this is the increase in length by FC dash, change in length by original length is my linear strain. FC dash is the change in length by original length is my AC. Okay, which can also be written as AF, AC dash by A. Okay, this is the linear strain. So from this equation, I know that I can substitute this from, if I call this as 3, gamma is equal to 2 times FC dash by AC, from, or substituting 4 in 3, I can write gamma is equal to 2 times FC dash by AC FC dash by AC, which is equal to 2 times FC dash by AC is nothing but FC dash by AF, which is nothing but 2 times epsilon. 2 times epsilon, or epsilon is equal to gamma by 2. When I subject the parallelepiped to shear stresses, the diagonals are subjected to linear strain, which is half of the shear strain, which is of magnitude half of the shear strain. This is positive along the positive diagonal. Similarly, for negative diagonal, it will be minus gamma by 2. Okay. Now, relationship between E, G, and nu. Relationship between E, G, and nu. Let us consider, let the tensile force along diagonal AC dash, let the tensile stress along a diagonal AC dash be sigma x, which is nothing but equal to tau. Let, since this is a normal stress, I am indicating it by sigma x. Let the compressive stress along diagonal AC dash, along diagonal BD dash, along diagonal BD dash B. So for derivation purpose, I'm taking this for sigma. Let it be sigma. I'm calling it as sigma y and sigma x and sigma y. And since it's compressive, indicating by tau, and there is no sigma z or sigma z is equal to 0. I'm expressing this my tensile stress. I'm indicating instead of tau, I'm representing it as sigma x and sigma y. That's it. Okay, for derivation. Okay, we know that epsilon strain along x-axis or strain generally is given by sigma x by E along if we consider along the x-axis only, minus nu times sigma y by E minus nu times, right? According, let's right. Okay, this is not required, not works now. Then it's 3 mutually perpendicular. We know that sigma x by E minus nu times sigma z by E. I can write epsilon is equal to sigma x is tau by E minus nu times tau by E minus of mu tau. This should be plus tau plus 0, or epsilon is equal to shall I write tau by E into 1 plus mu. Okay, this is a lengthy derivation, but they will ask for 10 marks. Epsilon is equal to tau by E into 1 plus mu. Also, I can write epsilon we have derived here. Epsilon is equal to gamma by 2. Gamma by 2 is from phi gamma by 2 is equal to tau by E into 1 plus mu, or I can write tau is equal to G times gamma, okay, or tau by G is equal to gamma. If I substitute tau by G in place of gamma, tau by 2G is equal to tau by E into 1 plus mu, right? Now, if I cancel out tau, I will left out E is equal to 2G into 1 plus mu. This is the standard relation. This is the relationship between Young's modulus, rigidity modulus, and Poisson's ratio. If I know rigidity modulus and Young's modulus, I can find Poisson's ratio. If I know Young's modulus and Poisson's ratio, I can find rigidity modulus. These relations we will be frequently using in order to solve the problems. Hope you understood this, right? Any doubts? Even though this is lengthy, but quite interesting. You will coming to know many concepts. Starting from the scratch, I'll explain once again. I'll give an overview. First, what I've explained, this is the relationship between we have derived. This is complementary shear stresses. For equilibrium, there should be one more force acting in the downward direction for reaction force, and this reaction force, this summation of forces become equal to 0. This leads to clockwise movement. For equilibrium, there should be anti-clockwise movement also, and this leads to complementary shear stress theory. Risk that shear forces are complementary. If it is acting on one of the plane, other shear stresses will be complementary. This free. Okay. Next, if I want to, if I derive the relationship between E and G, E nu and G, let us consider parallel perpendicular cube, and I'm writing the forces acting on the planes. These are the forces acting on the planes. Now, if I take a section like this, the thickness is 1 unit, but we should understand that one of the diagonal is under tension, the other diagonal is under compression. This is under tension, this is under compression. So how I came to that conclusion is from law of paranormal forces. If I take the reaction force, the reaction will be acting, that the diagonal is the resultant. The resultant, if you see that, this resultant will be acting from this point, from this point. Similarly, I have drawn the resultant from this point. This is the resultant is acting like this. This is under tension. This should be also for equilibrium. This should be one force acting in opposite direction. Similarly, if you take other half of the body, the other half of the body will be under compression. Okay, after that, after we came to know this forces, I evaluate the area. Area comes under to be root 2a. If I divide the resultant force by area, I'm getting the normal stress. I know the normal stress. One of the diagonal under tension, other under compression. Now, by geometry, we'll prove that we know the shear stress is change in angle. Change in angle is this is the CC dash. This is gamma CC dash by original length BC, and I came to know we have derived that, and we have obtained gamma is equal to 2 times FC dash by AC. That is our linear strain is half of the shear strain. Next, I will assume that my normal stress, since the tau is nothing but normal stress along the diagonal, and the other is compressive stress, is also the normal stress. I'm just indicating it by sigma x and sigma y for my convenience. If I substitute in this sigma x by e minus 2 times sigma y, since there is no sigma z, is so this turns out to be e epsilon by tau by e 1 plus nu. If I substitute according to this relationship, shear stress is proportional to shear strain within proportionality limit. If I substitute, I'll be ending with the relationship E is equal to 2G into 1 plus U. This is a standard relationship. Is there any doubts? Is there any doubts?
No, sir.
Have you understood this? Have you understood this? ಅರ್ಥ ಆಯ್ತಾ? Hello? Have you understood this?
Yes, sir.
Okay. I'll go ahead and derive another 2 more derivations. Relationship between EK and mu. Second derivation. Relationship between E, K, and mu. Let us consider similarly parallelepiped or a cube subjected to instead of compressive, it's one and the same whether you apply compressive force or tensile force. I am taking sigma tensile sigma tensile, sigma tensile, sigma tensile, and sigma tensile, like this. Relationship between E, K, and mu. Relationship in E, G, and mu was E is equal to 2G and 1 plus mu. Now, if I take, we know that uh, bulk modulus K, which is equal to normal stress sigma by volumetric strain. Volumetric strain is given by sigma x plus sigma y plus sigma z by E into 1 minus 2. We have derived this. Our volumetric strain, since sigma x is equal to sigma y is equal to sigma z is equal to sigma. In this case, when take a body and immerse in fluid, it is under I. For example, you will immerse a cube in a sea. Then it is subjected to pressure of equal magnitude on all the surfaces that you can imagine. So this will be sigma. I can replace epsilon v is equal to 3 times sigma by E into 1 minus 2 nu, or k is equal to sigma by 3 times sigma into E into 1 minus 2 nu, or E is equal to, have I done anything mistake? E is equal to sigma 1 minus 2 nu, sigma 3 sigma by E into 1 minus 2 nu. Sorry, this in the denominator. 3 sigma by 1 minus 2 nu, minus 2 nu, 3 sigma 1 minus 2 nu, or E K, or K is equal to, or E is equal to 3K into 1 minus 2. This is the relationship between E, K, and nu. These are all generally asked for 4 to 5 marks. Okay. This is one of the derivation. These are very simple. Problems are very simple. You substitute in this formula and obtain the results. Okay. Next, relationship between relationship between E, G, and K. E, G, and K. E, G, and nu was different. E, K, and nu was different. E, G, and K. Okay. We know that E is equal to 2G into 1 plus mu, or E by 2G minus 1 is equal to nu. E is equal to 3K into 1 minus 2 nu. Okay. Or E by 3K is equal to 1 minus 2 nu, or 2 nu is equal to 1 minus E by 1 minus 2 nu E by 3K, or nu is equal to half, another 10 minutes left, of 1 minus E by 3K. Substituting from 1 and 2, 1 is equal to 2, nu are equating equating 1 and 2. All right. E by 2G minus mu is equal to half into 1 minus E by 3K. Okay. Or I can write E by 2G plus E by 6K, which is equal to half plus 1. After I've taken, I multiplied by half, E by 6K, If I take the LCM, this is 213, 6 is the LCM, 6 is the LCM, 2 3 is 6, or I can write E into 6GK, 6GK, 2G cancels, 3K, 6K cancels, G is equal to 3 by 2, or I can write E is equal to 3 by 2, 3K plus G, 6GK, or E is equal to 18, 18GK by 2 into 3K plus G, or E is equal to 9 kg by 3K plus G. This is one more relationship. 9 kg by 3K plus G. The three relationships which I have derived. The first one, relationship between E, G, and nu, which is E is equal to 2G into 1 plus nu. Relationship between E, K, and mu, which is equal to E is equal to 3K into 1 minus 2 nu. The third one is relationship between E, G, and K, which is E is equal to 9 kg by 3K plus G. Any one of the derivations can be asked in the examination. Okay. In the next class, tomorrow's class, if possible, I'll take one more class. We will be solving the different types of two or three problems, which are very simple. But just by substituting in these formulas, we can obtain the results. And also, I have left with one more section. There is a composite section, which I will complete after the internals. I have not seen. I thought it was not for you in the syllabus, but 18MT 33 question paper, I saw it. They have given. I have uploaded that question paper and also in the Google Classroom. From that, you can make out that they have asked the problem on composite section. Okay, steel rod of cross section, something like that. It's for 8 marks. Okay, we will solve the composite section, and that completes your first model. Next week also we may take another 3-4 classes for that. Okay, I'll finish at this point. Any doubts you can ask me. Any doubts you're having? Any doubts?
Sir, what is the last formula, sir?
That is E is equal to 9 kg by 3K plus G.
Sir. Sir, the derivations for these formulas are important, sir, or only for understanding, sir?
Derivation they can ask, obtain the relation between E, G, and K. For 6 months they will ask. Or why it is required is if you know K and G, you can obtain Young's modulus. For isotropic elastic material, if you know the relationship between K and G, you can obtain your E. Or if you know the relationship between bulk modulus and Poisson's ratio, you can obtain E. If you know G and E, you can obtain Poisson's ratio. Similarly, this type of numericals will be asked. Or you can also, if you are doing any experiment, if you know any two values, you can relate it to the other unknown, you can evaluate it. Right? Hello?
Yes, sir.
Okay, shall I stop at this point?
Yes, sir. Thank you, sir.
Thank you. Any doubts you can ask me. If you have any doubts, you can ask me. Tomorrow's class, I'll be solving 2 or 3 problems that will complete. That will part of around 80 to 80% of the first problem will be completed. And the composite section will take in after the internals. Yeah, thank you.